All right, so on the back of the notes, I want you to go ahead and fix something before we start. This one was supposed to say 2x plus 5, not 2x plus 9. So if you just scribble that out and change that to a 5, you can actually solve the question if it's a 9. It's not like it doesn't work, but I didn't mean to make it as tricky as it is if it's a 9, so I meant for it to be a 5. The directions to this question say if angle 1 and angle 2 are complementary, so remember complementary means they add up to 90 degrees, they want us to solve an equation for x to figure out what the measures of each angle are if this is what the first one is and this is what the second one is. So it's important that you recognize that you don't know how big this one is, you don't know how big this one is, but you know that they add up to 90 degrees, and so you can create an equation that lets you solve for the missing part. I don't know how big the first one is, but I know it's 3x minus 10, and then I don't know how big the second one is, but I changed it so that it's 2x plus 5, and I know that they're going to add up to equal 90 degrees. And so 3x plus 2x gives me 5x. Notice that those are on the same side of the equal sign, so I'm solving by combining like terms. Negative 10 and positive 5 gives me negative 5. So again, I combined like terms because they're on the same side of the equal sign. And then when I finish solving, I'll add my 5 to both sides. I'm going to get 5x is equal to 95. And so when I divide both sides by 5, that'll give me my final answer for x. So I'm going to get x is equal to 19. This question's helpful for people that are beginning learning this because it gives you 3 blank spaces. I could have asked you this question without giving you this as a prompt, and you still need to remember that when you solve to find x, you're not finished. You still have to plug it into the first angle right here, and then you have to plug it into the second angle because the directions to the question said, what are the measures of each angle? So when I do that, I'm going to say the measure of angle 1 is equal to, and I'm going to plug my 19 in for the x right there, and then I'll do the same thing with the measure of angle 2. So I'm going to plug the 19 into both problems, and then I'll just go through and I'll simplify them. 3 times 19 is 57, and then 57 take away 10 gives me 47. So the measure of angle 1 is going to be 47 degrees. Before you start solving for the second one, it's good to think about if you know they add up to 90, and if you know that this one's 47, the other one should be 43. So if I do the work right now, and if I get an answer that's not 43, that means that I know that I made a mistake, and I can go back and I can try to fix it. 2 times 19 gives you 38, and when I add up 38 and 5, I get 43. So if I get that this one's 47 degrees, and if I get that this one's 43 degrees, I'm pretty sure that I'm right because these two should add up to 90 degrees. And so since they do, I can be pretty confident that unless I made a mistake solving for x right here, I got the answer to the question right. Okay, if this question had said that they were supplementary to one another, you would have done everything the same, except you would have added them up right here to equal 180, not to equal 90 degrees. And then in your work over here, when you check your answer, these two should add up to equal 180 degrees, not add up to equal 90 degrees. So we used 90 because the directions to the question said complementary. Sometimes when you're solving, like in example 6, you're not going to be given a written description. You're going to actually be given a picture. We've solved this question in a review assignment before. We've never done this one before, though, I don't think. In this picture, ABD and DBC form a linear pair, so it's 2 angles that are adjacent to each other that form a straight line. We know that straight lines always equal 180 degrees. So when I'm solving this one, I don't know how big this one is, I don't know how big this one is, but because it's a linear pair, I know that straight lines always equal 180, so I know that this one plus this one equals 180 degrees. And so I can solve by simplifying, combining like terms on the left. The 6's cancel out. And when I divide both sides by 15, I'm going to get x equals 12. This is an example of a question where you have to make sure that you go back and read the directions. That's actually something in geometry that I really try to emphasize with students. It's super important to go back and always read the directions to a question because they might be asking you to solve to find the measures of the angles, and if you just solve for x, this is right, but it hasn't actually answered the question. So to find the measure of angle ABD, I'm going to go back and I'm going to plug the 12 in for the x on this one. So the measure of angle ABD, that's going to give me 48 plus 6. And so I'm going to get 54 degrees. So that's one of my answers to the question. But then they also want me to plug it in and find the measure of angle DBC. Now it is true that if you wanted to, you could just do 180 take away this, and that's going to give you the answer for this question. But because we're going through, and I'm the teacher, and we're doing all the steps for the question, it might actually be beneficial, 132 minus 6, for you to go through and actually finish the part where you're plugging it in, because this is going to let me figure out if I made any mistakes. So I plugged it in on this one, and I got that one of my answers was 54. And then I plugged it in on this one, and I got that one of my answers was 126. But the good thing that you can do is you can check. If they make a straight line, they should equal 180 degrees. And so when you look at this question, this one plus this one does equal 180 degrees. And so as long as you got the right answer for x, that's good, and it means that your answer is probably right. Okay. In the second example in this question, there's a couple of different ways that you can go about solving it. So take a second and just look at the picture. Remember that the box means that this angle is 90 degrees. And then that's kind of where you want to stop and decide how you want to move forward. There's two ways that I could set up an equation to solve for this. If you look at the whole angle, ABE, that makes a straight line. So that means that this one plus this one plus this one equals 180 degrees. And so you could set up and solve that equation. A lot of times those students recognize that if you just cover up this part, these two angles have to equal 90 because the box over here means that this one is already 90 itself. And so in that case, when you write down your work for this question, you could say 2x plus 3x is equal to 90 because that 90 is left over for these two. If you said 2x plus 3x plus 90 equals 180, then you would get the same answer to the question. You would just start by minusing the 90 from both sides, and this would be the second step of your work. Notice how when I combine like terms, they're on the same side, so I just add them up. And when I divide both sides by 5 on this one, I'm going to get x equals 18. But that's not the answer to the question because they wanted me to find the measure of angle ABD and the measure of angle DBC. So I have to plug it into this one and plug it into this one. And so that's the work that we'll do over here. Whatever you get for this angle and whatever you get for this angle, they should add up to be 90, not 180, because this part's 90, so these two should equal 90. The measure of angle ABD is 2 times 18. And so when I do 2 times 18, I get 36. So that's one of my answers. Sorry, that 8's a little crazy. There we go. And then when I do the other one, the measure of angle DBC is 3 times 18. And so for that one, I get 3 times 18 is 54 degrees. And so I knew that they were supposed to add up to 90. And so when I'm finishing this question, I'm checking my work and I'm making sure that they add up to 90 degrees. And in fact, they do add up to 90 degrees. 54 and 36 do add up to 90. So as long as x equals 18 was the right number, it means that I know my answers are correct. So we'll do some solving in the last example, but right now we're just going back to the definitions and we're practicing the vocabulary. This might actually be a really nice place for you to pause the video for a second and try to answer these questions by yourself, and then just go back. You can fast forward it if you want to, and make sure that you have the right answers to the question. It says, tell whether the angles are a vertical pair, so that's one option. Tell whether they are a linear pair, so that's a second option. And then the third thing says, or tell whether they have neither, so they have no relationship. So you're going to write down either this word, or this word. And then it says, say whether they're congruent, whether they add up to something, or whether they have no relationship. So after you pick one of those words, then you're going to go through and you're going to answer this part of the question. So it has two parts to it. It's good to point that out. Angle 1 and angle 2. If you cover up 3 and 4, angle 1 and angle 2 make a straight line. That means that they're a linear pair. And all angles that are linear pairs add up to 180 degrees. So that's kind of the format that you can use. Feel free to pause the video and work ahead if you'd like. Otherwise, you can just work along with me. Angle 1 and angle 3 are opposite from each other. They're not next to each other. They don't make a straight line. I like to use the word across when I talk about these. So angle 1 and angle 3 are vertical angles. And vertical angles are always congruent. So they're equal to each other. Angle 2 and angle 4 don't make a straight line. They're also across from each other. So angle 2 and angle 4 are vertical angles, which means that they are congruent. Angle 5 and angle 7, this one's tough. So angle 5's over here and angle 7's over here. Angle 7 and angle 6 kind of look like they're similar to one another, but we don't have enough information to say that for sure. So since 5 and 7 aren't on the same crisscross, we say that they are neither vertical angles nor a linear pair. And if they're neither, that means that they have no relationship that we can state. And then for angle 5 and angle 8, so 5's on the outside over here and 8's on the outside over here, those two angles are also not on the same crisscross, so we're going to say that those are neither and that they have no relationship. In the notes that we do tomorrow, we're going to be talking about lines that are parallel to each other. And so in the notes tomorrow, you'll be able to say a little bit more about angles that are on different crisscrosses or different intersections of lines. But for today, we don't know anything to say anymore about them. So you're just looking to see whether the two angles add up to be in a straight line, so 180, or whether they're across from one another and they add up, they're congruent to one another. And so the final example on today's notes has you practice using the properties of vertical angles and using the properties of linear pairs to help answer questions. Before we start, I want to point out that some of these have x's and some of these have y's, and you can't solve an equation with x's and y's unless you get really fancy and you want to solve a system. So when I set these up, I'm going to make sure that I set them up in such a way so that you only have one variable in each equation. So when I do this first one, these two angles are across from each other, so they're vertical angles, so they're congruent to each other. But I don't want to set 4y equal to 9x plus 5, because if I set those equal to each other, then I can't solve for either x or y because there's two letters in the problem. So I'm not going to start there. Instead, I'm going to cover up these two angles, and I'm going to say that these two, so 16x and then 9x plus 5, form a linear pair. So I know that those two angles have to add up to equal 180 degrees. So I'm going to say 16x, the first one, plus 9x plus 5, the second one. I know that it has to equal 180 degrees. And so because this equation only has x's in it, I know enough to go through and solve it. I'm going to combine like terms on the left. So I put the 16 and the 9 together, and that's how I get 25. Then I'll minus 5 from both sides. And then to finish it, I'll divide both sides by 25. So I'm going to get x is equal to 7. So this question said to figure out what's x and y. It doesn't say that I have to do anything with that 7 when I'm finished. So once I get x equals 7, I have one of my answers to the question. And all I have to do now is either use the 7 somewhere or set up a different equation to solve for y. So if I look up at my question, there's a few ways I can use this 7. I could plug the 7 in here, and I could do 16 times 7 equals 112 degrees. And then if I know that about the problem, then I could use this information to find out what y is equal to. I could also take the 7 and I could plug it in here. So if I did 9 times 7 plus 5, 9 times 7 is 63 plus 5, so that gives me 68 degrees. And so if I know that this angle over here is 68 degrees, by the way, notice that those two add up to 180. That's a good thing to notice. If I know this one's 68 degrees, then I could use vertical angles. So on your paper, you may want to make a note that says that there's more than one way that you can set up an equation to solve to find the rest of what you need. For this one, you can decide. So your two choices for equations are either to say 4y plus 112 equals 180, or you could say 4y is equal to 68. And so you could use either of those to solve to answer the question. If you use these two, you're adding them up to equal 180 because they're a linear pair. But if you use these two, you're setting them equal to each other because they're vertical angles. And so you might want to try to solve it differently than I do over here. I'm going to use linear pair. Why not? So I'm going to say 4y, this one, plus 112, this one, has to equal 180 degrees. But if you did 4y equals 68, you're going to solve and get the same equation. Because look what the first thing is that I'm going to do. I'm going to minus my 112 from both sides. 4y equals 68. And when I divide that by 4, I'm going to get 17. So in this picture, if x is 7, y is 17, and then that makes all the numbers work out for vertical angles and for linear pairs. Okay, the next question has a little bit more information on it, so it has more numbers on it. I'll just adjust the papers here for a second. So when you're doing your work for this one, I always encourage you to figure out which ones have x's and which ones have y's. So the top one has an x, the one on the left has a y, the one on the right has a y, so those we'll use in a second, and then the one on the bottom has an x. So when I'm setting up my equation for this one, I could say this one plus this one equals 180, and this one plus this one equals 180, but then I'm going to have x's and y's in the same equations, and I'm going to have to use substitution or elimination, and it's been a long time since we've done that. So for my question right here, I'm not going to use linear pairs, I'm going to use vertical angles. So I'm going to use the fact that I know that the ones that are across from each other are equal to each other, and then the ones that are across from each other are equal to each other. It is not because they have the same letter. It's because that's what's true about angles. These ones are across from each other. They are equal to each other. It doesn't matter that this one has y's and this one has x's, but they're equal because they're vertical angles. So when I set up and solve my equations for this one, I'm going to say 11x minus 24 is equal to 7x plus 30. And then I'm going to do my math for my other one, and I'm going to say 5y plus 38 is equal to 17y minus 4. So I'm setting the yellow equal to the yellow and the pink equal to the pink because they are vertical angles. These x's are on different sides, so I will minus minus to solve. And then I'll add the 24 to both sides. You're going to get decimals for this one, but that's okay because decimals are your friend. When you divide both sides by 4, it's okay we can turn this into a decimal. It works out to be an exact decimal. So I get 13.5, 13 and a half. And then when I solve this one, I happen to get a decimal, but again, it's just coincidence. So let's see, for this one, I'll minus the 5y to both sides. So I'm going to get 38 is equal to 12y minus 4. Let's see, 42 is equal to 12y. And so when I divide this side by 12 and divide this side by 12, I'm going to get y is equal to, let's see, 3.5. And I just did that on a calculator. So there you go. It is worth mentioning that in this question, when you get your two answers to the problem, just because they're decimals doesn't mean that you can't use them to check your answer. So I can plug in, this one's the y, so I can do 17 times 3.5 minus 4. 17 times 3.5 gives me 59.5. And so when I take 4 away from that, I get 55.5. And so that was plugging in the y for this one. So when I come over here, and when I plug in the y for this one, so 5 times 3.5 plus 38, 5 times 3.5 plus 38. And when I add those two numbers together, I get 55.5. It's important for me to tell you that what I'm doing right now is I'm just checking the question. So the work that I'm doing right now on the paper isn't part of the question. They just wanted me to figure out x and y. But a smart student on a test is going to want to make sure that they're getting them right. So if I plug in my y here and my y here, and I get that these two are equal, it means that my math was correct. And then I would also need to plug in my x here and plug in my x here. So let's see. So 7 times 13.5 plus 30. 7 times 13.5 is 94.5. And then when I add 30 to that, I get 124.5. So two things. These numbers have to add up to equal 180 because they make a straight line. These numbers have to add up to 180 because these make a straight line. And when I do my very last part, which I'm going to kind of have to squish in right here, but when I plug in the 13.5 for this x, I also have to get 124.5, or it means that I made a mistake somewhere. Geometry does have a lot of opportunities for you to go through and check things. You just have to know how to work the numbers so that it works for you. 148.5 minus 24. And so I get the same answer that I was trying to get, so 124.5. So the amount that you have time to go back and check your answers will depend on a lot of things. It'll depend on how quickly you study and how fast you can move through the problems. But being able to do that on a question like this is really nice because it means that you can know whether the two answers to the questions that you got were correct or whether they were not. So you guys remember, there's no MyHRW homework that you're doing tonight, even though they're going to pop up later on today, or maybe they've already popped up online. You're going to wait and not do that. So my gift to you, since you worked so hard and you took the test early this week since I was going to be out of town, is that you don't have to do the MyHRW homework tonight. We're going to go ahead and push that to next week. For the rest of class today, your job is to find something to work on quietly. So you can work on homework for a different class. If the sub says it's okay, you can listen to some music as long as it's quiet and it's not distracting anybody else. And then we'll pick up tomorrow. We'll do the notes for 19.2. And then on Monday, we'll go back and we'll talk about these notes together before you work on the assignment. So no homework online tonight. Thanks, you guys.